get started. We have got a lot of questions to get finished in the time that we have. We're going to finish off 15.2. Obviously, that's where we need to be so that you can do your test and get your homework done. We're looking at double integrals over general regions. And I'm going to set up the double integrals in most cases, but won't take them any further. Hopefully, we've done enough practice to know how to do the details after that. So my first one is going to be this guy here. Very often, it's a good idea, if you can, to sketch the region D so you've got an idea whether you're going to go type 1, which is vertical, or type 2, which is horizontal. Here we have y equals x squared. And why am I doing this? I'd set it up already. So what I would do, unless it's an obvious one at least, I would use Desmos in the more awkward one. So here, Desmos. Come on, there we go. So the two guys that make up the region D are y equals x minus 42, which is, better be a straight line. Yeah, there is, so that's straight line there. And then the second one was given in terms of x equals y squared, which I hope Desmos can handle, and it does. Desmos is so cool, right? So if you're looking at the region D, it's basically this piece here. Can you see it where the red line meets the blue? Now, when you look at that question, would you agree going vertical isn't going to work? So aren't we going to have to do horizontal rectangles? Right. So I'm doing a very baby version of that on my paper right now. And we'll now set up the limits of integration, because that's what I want to focus on today, how to set up the limits of integration. So this is going to be D, right? This guy here is x equals y squared, and this is the straight line, y equals x take away 42. And you have to realize that in this case, we're going to go that way, aren't we? Agreed? Now, I need to know that guy. I need to know that guy. You can't see it, but I'm going back to Desmos and I'm clicking on it. And when I click on that guy, it's 36. This fella here is -6. When I click on this guy up here, it's 49.7. So this is 7. So I got these two values by just using Desmos again, right? So time to set it up. Y is going to go from -6 to 7, right? So it's going to scan this way. And then the x's are going to go from that guy, which is the little one, to this guy, which is the big one. Now, the little one is x equals y squared. This guy is a straight line, but that is no good to me. I have to rewrite that. Are you comfortable with x equals y plus 42? Are you now happy on how this region is described by this values? Y going from -6 to 7, and x going from y squared to y plus 42. So my double integral, which is this guy, is going to have the numbers here, right? The numbers always go at the end. Then, in this case, the lower one, up here, the upper one, and then the function. And then in this case, it's a dx, and then it's a dy. And we are done. Are you comfortable that I've now set up the limits of integration based on the information in front of us? Now, won't you just do the usual, which I'm not doing today, is integrate that with respect to x and then integrate the answer with respect to y. And that's...
Would it be y plus 42 and not x plus 42?
Did you all catch that deliberate mistake? Yes, it should be. Question 15, or a version of 15, the region D is going to be y equals x, which is this guy, and y equals x cubed, which is this guy. This one I'm doing by hand, but I could do it in Desmos. And it says x is greater than or equal to 0. Now, if you do x is greater than or equal to 0, aren't you only talking about this banana, not the whole banana, right? So y equals x cubed, and x greater than or equal to 0 defines the region D. Can I do this as a type 1, vertical rectangles? Can I do this as a type 2, horizontal rectangles? Or can I do it as both? Which one can I do? Can I do vertical? Let's do that.
Either one.
Yeah, either one. If it's either one, would you probably just err on the side of keeping it the way it is, because there's less work. So I need to know that guy, which is obviously 0. If I had Desmos, that would tell me I'm 1. My vertical rectangle would be this guy. And so x's would go from 0 to 1, and y's would go, okay, you got to make sure you get these the right way around. What is the smaller value? Is it x or x cubed? What goes here?
X cubed.
Right. Isn't it the low one, right? And the low one is a curve. So it's x cubed on this side, x on that side. So our integral is going to be from x equals 0 to 1, from y equals x cubed, the bottom, to y equals x, the top. Nothing ever happens to that guy. And since I'm doing y's first and then x is second, that's going to be the order of integration, right? The limits of integration. So quite visual, right? Draw a picture, do Desmos, find the limits of integration, either using vertical or horizontal triangles, whichever one lends itself to the situation. That'll give you the limits of integration. That guy's the same. And then you should be able to figure out dx dy or dy dx. Once that's done, you just do it the usual way. Feeling that I'm going fast here, but is it okay? Am I not? It's not too fast, right? Next one. Doing this guy. And D is a triangle formed by the points 0, 1, 1, 2, and 4, 1. I feel I've seen this before. Have I done this one before? No? Okay. Then there's D, right? Now there's more information that I need before I'm ready to set up, the range of x's and the range of y's. But the first thing I'm going to decide here right off the bat is, I do remember doing this one, but never mind, we'll do it again. Am I going to go vertical or horizontal? Because only one of those is actually going to be of any use in this triangle. And it may be that this just is very similar to one I've done. But horizontal rectangles or vertical, which way shall I go?
Horizontal.
Correct. Mia, what made you decide that? It's the right thing.
Because the y values, they're easier to find from 1 to 2, and then the x values are harder to find because of the slopes.
Yeah. Okay. So right now, just like Mia said, the y values are pretty easy, aren't they, from 1 to 2? And now the x values, you're going to get them from these two lines, agreed? Now, aren't those two lines going to have to be written down as equations of lines and then rearrange those equations to be in the form x equals. So first we'll get the equations of the lines the usual way that you get equations of lines, right? So y equals 2x plus 1 kind of thing. So this line here, the one on the left, it passes through the y-axis at 1, and it passes through 1, 2. So if you go along 1, you go up 2. Would you agree that the slope of this line is 2, right? 1 along, 2 up. And would you agree its y-intercept is 1? If you put that package together, can I write y equals 2x plus 1 without going into too much detail? Right? Y-intercept at 1, its slope is 2. Right? That one is good as it gets, but I know that I have to rearrange that. So if you subtract 1 from both sides, then divide both sides by 2, again, I'm cutting out a few corners, but are you comfortable you could figure out why that becomes x equals a half y, take away a half? Does that make sense? Just rearranging the question. Now, that guy is going to be the small one, right? So that's going to be the guy that goes here. Now, to get this second line, things are a little bit more work. That line is definitely negative, right? If you do a rise over run, that's 3 boxes going that way and 2 boxes going that way. So I know the slope of the line is negative 2/3. I know the point, well, I can choose that one or that one, it doesn't matter. But one of the points on the line is 1, 2. And so if I call this guy x1, y1, won't I have to do the point slope equation, right? This one's a little bit messier. So y take away y1, m brackets x take away x1, y take away 2 is negative 2/3 x take away 1, negative 2/3 x plus 2/3. If you add 2 to both sides, I believe you get 8/3. So that line is negative 2/3 x plus 8/3, which is fine, but it's not what I need. I need this to be written in x equals form. So I'm going to take the equation of the line. And I could do this lots of ways. The way I'm going to do it is I'm going to multiply everybody by 3. And then I'm going to subtract 8 from both sides. And then I'm going to divide everybody by negative 2. And there we go. There's the guy. So our integral is going to be from y equals 1 to 2. And it's going to be from x equals this guy, who was a half y take away a half, to this guy, who was, hopefully I did this right, negative 3/2y plus 4. And the function in 16 is 7y squared. I'm doing x's first and y's second. And we're done. So kind of different situations, right? Require different ways of approaching them. Well, there's 3. Can I set up? Next 3. D is a quarter circle, so I don't need Desmos for this. That's a quarter circle with x greater than or equal to 0. If you look at that equation, is it okay for me to put the 0s and 5s? Are you comfortable how I know that the radius is 5 from this equation? Are we good? Right. I mean, if you want to square both sides and do some stuff, and you'll get the equation with the radius of 5. This one here, I'm going to go straight into doing vertical rectangles. So if I do vertical rectangles, the curve is going to be that guy. And so x's is going to go from 0 to 5. And y is going to be from 0 to an ugly square root. So my integral will become x equals 0 to x equals 5 of y equals 0 to y equals that ugly guy, x dy dx. And this one I'm going to take a little bit further. So let's focus on the first integral. If you integrate x with respect to y, what do you get?
xy.
Just xy. Evaluated at y equals 0 to y equals ugly square root. And so you're going to get the integral from 0 to 5. If you plug in y here, you get x, the square root of 25, take away x squared, minus nothing, so don't care about it. You get that guy. And of course, we end up with an integral that involves us having to use who? What method will I need to solve that guy?
U sub.
Yeah. Didn't we decide yesterday if you don't know what to do, look for a U sub? Isn't that rule actually working really well so far? And the U sub would be 25 minus x squared. On to 18 now. It says find the volume of a solid given by this plane and above that region. What we've not spoken about here, and I guess I'll do it right now, is that if you find that double integral, one way of interpreting it is that you're finding the volume of a solid, where the top is the value of the function xy, and the bottom of the shape is the region D, right? You know, like the rectangle and you go up. Well, now it's going to be a triangle in the bottom, but you go up, right? Or it's going to be half a circle and you go up. So a double integral can, and very often does, represent the volume of something. So in this question here, we have to just figure out a little bit more than before. We need to know who this guy is. But I want you to always think that Z is who f of xy is. So when you tell me that the plane is going to be 7x plus 2y take away z equals 0, if I rearrange that a little bit by adding z to both sides, can you see that I now know who my f of xy is? It's 7x plus 2y. Are you comfortable about how I found that? Now, that means my double integral over d is going to be for a 7x plus a 2y dA. And now I'll focus on the region. And the region is y equals x squared and x equals y squared. I could do that in Desmos, but since I'm kind of rushed for time and space, would you agree that that is y equals x squared? Are we comfortable with that's y equals x squared? And if I do x equals y, can you just trust me that it ends up looking like that guy? So isn't the region D that I-shaped? Are you comfortable so far? Now, if you did Desmos, it probably won't surprise you that those two numbers are 1 and 1 and that this is obviously 0. I think this is one of these questions, isn't it? You could go vertical, you could go horizontal, couldn't you? You could do vertical rectangles, or you could do horizontal. Would you agree they're probably equally, equal? Would you want me to do vertical or horizontal, since it doesn't matter?
Vertical.
Okay. So if I do a vertical, it's going to look like that. So if you do vertical, that means the x's are going to go from 0 to 1. And won't the y's go from bottom guy to top guy? Okay. The bottom guy is actually x squared. The top guy is him. But I would have to rearrange him to be that guy. Are you comfortable about the square root of x and why it's there? And so my limits of integration are going to be from x equals 0 to x equals 1, and from y equals x squared to y equals the square root of x. And the function is that guy. I'm going to do a dy and then a dx. And would you agree we're done, right? We've got the integral that's going to give me the volume. Yes, I should pause for a second here. Are we good? So far, so good. $19, we're being asked for a volume. So we know that's going to be essentially find the double integral. They've been a lot nicer this time. Haven't they told me what z is right off the bat? I didn't even need to rearrange it. So my function is going to be x squared plus y squared plus 1, right? Didn't really need to work on that one. Now, this region here is a little bit messy, but I should be able to do it. So let's see what we have. X equals 0 is the y-axis. Y equals 0 is the x-axis. You really didn't need to tell me z equals 0, because it would have to be, it's the floor. And x plus y equals 7 would be a line that looks something like this. And so the region D is that little triangular region. Would you agree I could do this as vertical type 1 or horizontal rectangles type 2? It worked both ways. Agreed? Would you want this time, horizontal or vertical?
Horizontal.
Horizontal. I'm glad you said I was fed up doing vertical. Right, horizontal. Now, if you're going to do, oh, by the way, are you comfortable that those two numbers are 7? Right, for the line x plus y equals 7, it crosses x and y axis at 7s. So now I'm ready. Since we're going horizontal, that means the y values are going to go from 0 to 7. And the x values are going to go from 0 to the line. And here is the equation of the line, but I want the line to be in terms of that guy or that guy. What should go here? 7 minus x? Or it's a minus there. Or 7 minus 1? Which is the only correct answer?
7 minus y.
Yeah. If the variable is x, don't the limits have to be in y's? If the variable is in y, don't the limits have to be in x? Do you notice that switch over, right? X is in the middle, limits are in y's. Y in the middle, limits in the x's. And if you get kind of back to front and confused, that might help you. So we're going to do y equals 0 to y equals 7. We're then going to do x equals 0 to x equals 7 take away y. And the function we're going to be doing it to is this guy. It's then going to be dx, because that's this one, and finish with dy. And there is the double integral that's going to give me the volume of that shape. Wow. Would you believe it? I didn't think I'd be this far ahead. Would you believe we are on the last one? So since we're on the last one, I'll do this one all the way through and I'll take my time. There's no rush. So, well, actually, why don't I use this? Find the volume of the solid by subtracting two volumes. Now, the solid is enclosed by this fella, and the planes are this one and that one. So we are looking at a lot of information, and we're being asked to find it by subtracting the volume of two solids. Now, the thing that's going to remain the same is this, because this bit here is the region D. So let's just focus on that and then worry about how we're going to subtract two volumes and how that's going to get what we want. So if you take 1 minus x squared, which is this guy, you are going to get a quadratic that looks like that. Can you imagine we did it in decimals? Does that seem reasonable? Now, if you do x squared minus 1, are you comfortable with my shape? So the region D is that big blob football shape in the middle. Now, I want to set up limits of integration for this region D. This one, only one of the two directions works. You can only do vertical rectangles. This is only going to work with the type 1. If I try and do type 2, I'm going from one curve to another point of the same curve. That's no good. It has to be one curve or line to another curve or line, right? That's why the verticals. So I'm going to put in my vertical. I guess I better change color. I'm going to put in my vertical rectangle and do a type 1 region. This point here has a coordinate of 1. This point here has a coordinate of 1. So the x's are going to go from 1 to -1. So far, so good. Now, won't the y's go from here to here, right? This is the low value, this is the high value. So the y's are going to go from this guy here, which is x squared minus 1. So on this side, it's x squared minus 1. And the high value is going to be 1 take away x squared. There is the limits that you need for region D. Okay, I'll pause a minute. Are we comfortable with that so far? Are you happy about the shape and how we got this? Anything you want me to talk about? Yeah, I got a thumbs up. Now I'm going to, again, pretend that we're not being asked to find the volume or the difference in two volumes. I'm just going to pretend they gave me one volume. They wanted to know the volume of that shape. Well, if you take x plus y plus z equals 2, don't you have to rearrange it to find out what z is? Because in that case, we now know who our function is. F of xy is going to be that guy. So the volume is going to be the double integral of the region D of this guy to y. And I know that the x's are going to go from -1 to 1, and the y's are going to go from x squared minus 1 to 1 minus x squared. And the function is going to be 2 take away x, take away y. And we're going to do dy and dx. Are you still with me? Right. So since I've got the time, let's keep going. So it's going to be the integral from x equals 1, well, -1, I should say, to x equals 1. If you integrate this with respect to y, you get 2y minus an xy minus 1/2 y squared, evaluated at that guy to that guy, dx. So we're going to get a volume from x equals 1, there I do it again, -1 to x equals 1, of 2 lots of 1 minus x squared minus x times 1 minus x squared minus 1/2 1 minus x squared squared. I am already regretting doing this question. Take away, in brackets, 2 lots of x squared minus 1. Take away x times x squared minus 1 minus 1/2 of x squared minus 1 squared. Okay, let's see it. This guy's going to get me 2, take away 2x squared, take away an x, add an x cubed, take away 1/2, take away 2x squared, which ends up being plus an x squared, add an x to the 4, which becomes take away 1/2 x to the 4. That's the first one. Subtract 2x squared, take away 2, take away an x cubed, add an x, take away 1/2 x to the 4, negative 2x squared with a negative gives me plus an x squared, and 1 take away that gets me 1/2. Okay. 2 take away negative add 2 gets me 4. A negative 1/2 take away negative 1/2 means you add it, so I get 4. Okay. How many x's have I got? Change color. I have got a negative x, take away an x, so that's going to get me negative 2x. Okay, there the x is taken care of. What kind of x squareds have I got? I've got negative 2x squared plus that guy, then that guy, and that guy. Goodness gracious. Negative 2 take away 2 is negative 4. That guy, take away that guy, cancel, so I get negative 4x squareds. What kind of x cubes have I got? I've got this guy, take away that guy, cancels out. So, okay, don't worry about them. Kind of x to the 4s do I have? I have this negative guy, take away that's add it. Oh, they cancel out. And I take it all back. Unless I've screwed up, that is a remarkably nice answer.
Isn't there a 2x cubed?
I should have a 2x cubed. Okay, let's check it. X cubed, take away an x cubed. You are correct. Anything else, or are we good? Okay, we'll continue. 4x minus 1/2 x squared minus 4/3 x cubed plus 2 divided by 4 plus 1/2 x to the 4. Evaluated at x equals -1 to x equals 1. You're going to get 4, take away 1, take away 4/3, add a half, minus -4, take away 1, add 4/3, add a half. 4 and 4 gets me 8. -1, add 1, dead. -4/3, -4/3 is -8/3. 1/2, take away half, dead. That's 24/3. Take away 8/3. Wow. God, that was a lot of work. 16/3. Anything obviously wrong, or does 16/3 look good? I know the method's right, so I just can't count. We haven't answered the question yet. We're getting there, but we haven't answered it. To remind you, what we've been told to do is to subtract 2 volumes. Well, I've only found 1 volume. And I am going to cheat now, based on what I've just done, and tell you that can't I now focus on this guy and the same region and do the same thing again. So let's show you what that would look like, but not the final answer. I'll cheat a little bit on that. Now, if you rearrange this guy, there's a plus. You get that. So basically, there's your function. So your volume for the second shape is going to be a double integral as well, but the function that we're using is that one. But this is the same. So I'm still going to do x equals -1 to x equals 1, and y equals x squared minus 1 to y equals 1 minus x squared. Right, so that's my second one. And the cheat is coming in there. Well, I can't actually do the cheat, so I'll do a pretend cheat. Can we pretend that we did all of this and it ended up being 7/3? Can you just pretend it's 7/3? I have no idea what it is, because the answer I've now got is for a different question, so I can't use that as a cheat. But can we pretend that it was? Right. So what we have is one of them was that, and the other one is that. Now that you've got these 2 volumes in front of you, what would be the volume between the 2 shapes? And they even tell you what to do. Don't you just subtract your 2 answers? Does that make sense?
Is there an order, like you're supposed to
I
do the
would,
first one?
yeah. Big one,
Okay.
take away little one. Make sure your answer's positive, because this is a physical volume in this case, rather than the double integral. So if you're being asked to find a volume of something, the double integral should be positive, because it's a physical volume, right? A thing in real world. So, I mean, if that ended up being 2/3, wouldn't I go 7/3 take away 2/3? That would have been the subtraction I would have used. Now, if it's a normal double integral, whatever that means, can't they be 5, -5, and 0, right? Just like the area under a curve, right? Normal double integrals can be any one of those combinations. But if the question is a volume, it must be positive, because it's a volume, right? So you would make sure that you got that. Oh, side issue. If for some reason I got these 2 guys back to front, in other words, I put them in the other place, what would be the answer? It wouldn't be 7/3 anymore. Everything else I kept the same, but I accidentally put these the wrong order. What
Wouldn't
would
it just be negative?
Yes. So if you do a really horrible long question like that, and you know it's a volume, and you got -7/3, aren't you just going to say oops and call it 7/3 and not do the whole question again from scratch? You know you're going to get 7/3, right? The reason you got -7/3, if that's the only mistake you made was, oh God, I know now that should have been the top and that should have been the bottom. If that's the only mistake you're going to make, then it's easy to fix, right? And in an exam, I would do exactly the same thing. So if you had an exam question and it was a volume and you got to the end and it was -7/3, you're just going to basically say volume equals 7/3 and something like switch the order of integration. So I know you weren't just guessing that there was a reason. Do you like double integrals? So? Can you handle them? The biggest trick, as far as I'm concerned, is if you can get the region set up, right? These guys here. If you can do that, most of the battle's finished with, isn't it? Just laborious sometimes, you know, big, long integrals, but nothing really too difficult, just long. And I think that's a really good place for us to finish.